I would like to welcome you all to our talk, a discussion of past, present, and possible future of bioweapons. I am Dr. Xavier Palmer.
I'm Meow, Ludo, Meow, Meow.
Hey guys, I'm Luke Potter.
Right on. So as a disclaimer, the perspectives and opinions shared in this talk do not reflect our workplaces. Further, this talk is designed to be a high-level, innocuous, and accessible talk. There's an extended open-end Q&A session to make this more fun and interactive, so we'll be brief with topics discussed at first. However, this portion will only be great if people get cool about a lot of things very quickly. That said, we'll discuss some past, followed by the future, as well as the present issues with bioweapons and just staying ahead of a lot of the hype around them. And this will lead into our QA session. Any more you want to say? Any more? Take it away, Meow.
Hello, Las Vegas, DEF CON. My name is Meow. I'm a biohacker from Australia. I'm going to be talking to you about the past of bioweapons. So I want you to take your mind back and imagine the year is 1348. A crisp spring breeze carries the smell of grass and salt water. You're a blacksmith that exports your wares via the port on one side of the city. The other side of your city is heavily fortified by two stone walls. Your city, Kaffa, has just entered its third year of the siege, caused by the Golden Horde, the descendants of Genghis Khan. Every morning you wake up to the familiar sounds of the clicks and thwacks of the trebuchets launching rocks at your town. Today, though, something's different. Instead of the reply being heralded by the sound of stone on stone, something different has happened. You look up to the sky for answers, only to find more questions. Is it a bird? Is it a plane? No, it's a plague-infested corpse being thrown over the walls. As the putrid bodies start exploding left and right, you and your fellow townspeople carry the corpses into the sea on the far side of Kaffa. Your hands have cuts in them, and unbeknownst to you, the blood of those cadavers is actually infecting you with a disease. As you begin to flee via boats to go to the rest of Europe, you're unaware that you're about to spread the deadliest bioweapon attack in the history of the human race. This attack caused the Black Plague to enter Europe, and it resulted in the deaths of about 25 million Europeans, which was about somewhere between a quarter and a third of all Europeans at that time. So were the Golden Horde that launched this attack the original biohackers? I think they were. They were using technology offensively by using a trebuchet to launch bodies. What's that? Could be either. Oh, okay. Okay. So they used the technology offensively. This is the first time. Okay, so before this, there had been kind of bioweapons attacks. Like people had sent plague victims into towns or chucked an infested body into a well. But this was the first time someone had used technology to attack people with a biological agent. And the results were absolutely devastating. To think of asymmetric warfare, one body thrown over a wall effectively killed 25 million people. So it's very powerful. Now, for the next 400 to 600 years, there were some variations on this. People were chucking, they knew it was effective to do this, throwing all sorts of bodies and cows over walls, letting rabid animals into towns and things, but it wasn't very directed. And I guess like this begs the question of what exactly is a bioweapon? So is this a bioweapon? Kind of, maybe, some people nodding heads. So by the strictest definition, I would say no. It's very cute, but would it need to have fleas on it maybe? Would that make it a bioweapon? Almost. If it has a pathogenic bacteria on some fleas, on a rodent, that would be a bioweapon. So the definition of a bioweapon is a virus, a bacteria, or a toxic compound produced by one used as a weapon. So for viruses, it might be something like Ebola. A bacteria might be the plague, and a toxic compound might be anthrax, the spores of Bacillus anthracis. So, and it has to be used obviously as a weapon, so it has to be delivered. If it just exists in nature, we wouldn't necessarily say it's a bioweapon. Some people might say it is, but they'll be wrong. And the thing that makes it a bioweapon is generally we use it to affect and do something, like kill something. So these are all popular ways that people have used to transmit bioweapons. So the gun that fires it, or whichever, it could be as simple as a blanket, as we saw with smallpox, which was deliberately used against Native Americans. It could be an arrow. Polish people in 17th century dipped the arrows in the blood and saliva of rabid dogs before firing them at enemies. A train carriage can be used to contain people. So we saw in Japan, there was ricin attacks. Agricultural bioweapons, which will, hopefully the audience will ask us a bit about, is like a really, really common one. And of course, smallpox attacks in the wake of September 11th. Anthrax attacks that were used on September 11th, which used envelopes. So in some ways, the USPS was part of the vector. I'm very careful every time I click the slide now. No one's shouting at me, that's all right. Okay, so it was basically bioweapons were this big nebulous thing where no one really knew what was causing them. So when the Golden Horde launched dead bodies into Kaffa, they thought that the bodies were cursed and that they were throwing the curse of God in, and that's what caused it. We know now that that wasn't the case. This guy, Louis Pasteur, he came up with the germ theory of disease, and this changed biological warfare, because when we worked out what was actually causing this, bioweapons changed from being a really common tool in warfare to being something that was kind of used by state agents and governments as a secret form of warfare. So we saw this a lot in World War I. Basically, different governments were using this to affect mainly agriculture and horses. So horses were used a lot in World War I. They were using them to make the horses lame so that they couldn't be as effective in warfare, using them to destroy give the cows diseases so that the army couldn't be as strong. And the net effect of this was that a lot of people got sick and everyone kind of agreed it was a bad idea. But the big change was that bioweapons became something that was invisible and people would deny using them. Kind of completely in opposition to throwing a body over a wall. Instead, they would infect some cows and then sell them to a farmer, and that would eventually cause problems in the neighboring country. I won't go heaps into it because from a biohack perspective, it's not really that relevant. It's just kind of good to know about. There's diseases we don't really hear about anymore, but basically they led to the Geneva Convention. Now, the Geneva Convention is important. It outlawed the use of biological weapons in warfare. It didn't outlaw their research, development, and stockpiling, and that led to World War II, when we saw Japan Unit 731 poison tens of thousands of people by poisoning thousands of wells with plague. We saw Winston Churchill was a big fan of using them. He dropped anthrax on a whole bunch of places, and the Nazis weren't really a fan of them. They preferred chemical weapons, but this led to the Bioweapons Convention, which was in the mid-70s. Now, this basically said, okay, well, we're not going to allow you to stockpile them anymore or research them for future use. The only problem is it's a voluntary convention that you sign up to. It's not enforceable nor auditable. This is still what we're regulated under, So every country signs up to it, and those countries continue to make biological weapons. Basically, any country that has the capacity to make biological weapons at some point has, which is terrifying. During the Cold War, we saw what this could look like. So the Soviets were stockpiling plague. They may have been stockpiling smallpox. Some of these stockpiles have not been recovered to this day. They exist in countries with like dubious attitudes towards this, countries like Turkmenistan that don't really have democracy or anything like that. We don't know where they are. We know that these places have had leaks. They've killed dozens of people when these leaks have happened. And it's all been shut down now, but we weren't aware about how large a scale this was happening until the fall of the Soviet Union. So we don't actually know what's happening right now at a state level, but at an individual level, it's definitely within our means to do it. That's the end of my part of the presentation. I'm going to pass across to Xavier now.
Thank you, Meow. So I need not bore you with the present, so I'll dive into what's important for making better sense of hype surrounding bioweapons and just biotechnology in general. I'm sure many of you are inundated with poor quality information on matters of biology and biotechnology from multiple angles and levels of power. What we all need are resilience and accessible spaces for them. I want you to think of your local bio, maker, and hacker spaces. And I also encourage everyone getting a library card and using interlibrary loan to get research and to learn. It's important that everyone gets used to also not exploiting your thinking about biology. Just as with how many of you in this audience have not done that for other aspects of technology in your life, it has long been since time for that in bio. So to stay ahead of the hype, to stay ahead of misinformation campaigns and disinformation campaigns, the responsibility is on everyone to develop comfortable and relative degrees of theoretical and practical literacy. What this eventually translates to is everyone learning terminology discussed, learning to parse and write literature, to understand institutional structures, to understand institutional responsibilities, institutional processes, institutional points of failure, and to better understand the nature of propaganda so that you can see hints of it in all media that you consume. No one is immune to bypassing it or getting influenced by it. But also, we need to make sure that we're also learning about systems of ethics and learning how they change. In short, don't stop learning. You may make mistakes from time to time, but that's okay, and it's part of the process. What's more dangerous if you decide to persist with a static understanding of the world and are not able to adapt to changes that occur and to new discoveries that emerge. It limits your ability to use new technology and to be abreast of new events that occur. But yes, I will hand this off to Lucas.
Hey guys, can you hear me? Great. So I want you to thank Xavier because I want to start my section's talk with the Oprah joke, hey, check under your chairs. And he said I couldn't do that, even though it would have been hilarious. So I'm here to talk about the future of bioweapons. So hopefully no one here goes on vacation thinking to yourself, oh man, I can't wait to get Lyme disease. I'm wondering if this place has tularemia. Maybe it has bubonic plague. That'd be awesome. If you do, please don't talk to me after this. We're going to talk about the future. So we've been through the past, we've been to the present, and I'm hoping we can all agree bioweapons don't sound great. I don't want giant baseball-sized lumps on my neck. I would rather not have smallpox. Hopefully you guys think that too. Okay. So here is the expected outline you probably wanted to hear for today. Introduction of future bioweapons, the synthetic biology, basically how to create them, talking in detail about CRISPR-Cas9, TALENs, ZFNs, and new genomic techniques. We're not going to do that talk because I like not being in jail, and I'd like to keep it that way. So we'll talk about them a little bit, but then move on to more basically practical issues or concerns. So let's go. So here's the genomic editing technologies. We have CRISPR-Cas9 up there. That's the really common one. That's the one the Odin used to sell kits for. It's very good at deleting genes, but not very good at putting in new genes, which makes sense. Usually the introductory exercise in synthetic biology is making E. coli grow in the dark. And of course, E. coli is a disease. You can modify any disease however you want with CRISPR-Cas9, theoretically. It just has some issues with changing it that we don't have time to get into, and again, rather not go to jail for, so we'll leave it there. We have transcription activator like effector genomic editing. Your talk beforehand was electroporation, all methods of getting DNA inside the cell and getting that cell to express different strands of DNA. We also have ZFNs, and that's basically what you guys probably thought we were going to talk about. I'm not sure you guys have the biological background to do it, but that's how you would change a bacteria or a virus, or, well, not quite a prion, a usual biological agent into being effective. Now, what we're going to talk about instead is something you probably are sick of hearing about. Who's heard of LLMs? Yeah, hopefully everyone. That's been the big talk for a while now. And here's an issue I think you guys want to hear about. So, the WMDP benchmark, Measuring and Reducing Malicious Use with Unlearning, is a paper about what ChatGPT knows about chemical, biological, and cyber threats. If you ask it politely enough, ChatGPT will tell you how to make a bioweapon. It's got to learn how to ask it. I'm not sure who at OpenAI let ChatGPT read the Anarchist Cookbook, but maybe he's not doing great at his job. The issue here is where most lone wolf or terrorist attacks get caught at. Who here went through a plane, used a plane to get here today and had to go through the TSA? Yeah, almost everyone, right? How many people think the TSA has caught more than 3 terrorist attacks? Yeah, they've historically caught nothing. The most frequent time attacks like this get caught is at the communication phase, when people are talking about doing an attack, which is an issue because with ChatGPT, you don't need to talk to anyone else. You need to talk to ChatGPT, and with the amount of requests they serve, you can't really verify all those requests. And as we've shown, they have that data already. Unless it unlearns it, you have access to it. Let's see. So that's the proliferative knowledge. We didn't really... There is nuclear and radiological issues here, but this is DEF CON. It's about biohackers. They're not going to have the chain of custody to get a nuclear weapon, hopefully. We'll keep saying that to ourselves. So now we're going to talk about killing with math. So who here today has a personal physiological model on them? Yes, you don't think you do, but if you have a fitness tracker, you kind of do. You have a ton of data on how you sleep, how your heart rate works. Basically, everything that you do that's tracked by a fitness tracker makes you more like you. There's a lot of mannequins nowadays. Oh, who's taken a CPR class? Anyone? Okay. You have the basic plastic mannequins you have to push up and down to practice CPR. They have more advanced versions of that. They have embedded in them with integrated systems the physiology of the person. So you can say, oh, hey, this mannequin lost this much blood, and now this is what's happening to its physiology. You can use that, which is an open source software, to basically predict your own physiological issues or make your own bioattacks to optimize them for a certain population, which means that no longer you have to worry about making tons and tons of biological weapons. You can go, okay, I've optimized this weapon to affect these people with these comorbidities. Go. And again, you guys are at DEF CON. You probably care about your data. You probably keep it secure. Hopefully most of your phones are in airplane mode. Your hospital doesn't do that. Every dollar they spend is at a dollar not treating patients, if they're a public one, or if they're a private healthcare system, a dollar not going to profit, which means cybersecurity falls by the wayside. If you really want to make an effective biological agent, you can use hospital records. Most of them are available for purchase if there's been a cyber attack on those systems. And of course, they cost a ton of money, which also goes well into funding your biological agents. This is a section we've written quite well in. I don't expect any of you guys to read that whole blurb of text, but basically you can make ChatGPT say things that are academic sounding and completely wrong. In this case, this paragraph here, if anyone's read it, you can laugh now, is about drinking gasoline to cure COVID-19. ChatGPT should not be able to tell you that. They put in safeguards quickly after ChatGPT 3.5 was released to make sure COVID-19 couldn't be said. We just swapped in respiratory infection. Same thing. You can make tons and tons of misinformation and make it really quickly. This actually came into a head with the paper, The Disinformation Dozen. Basically, the 12 people who spread the most disinformation on, I guess at the time, Twitter, now X, I don't know. I don't follow social media. None of them were really associated with a foreign actor. None of them had nation state ideas or ambitions. They just wanted to make money by selling you little crystals or saying, oh no, buy my weird colloidal silver thing to cure your COVID. They didn't necessarily have to have nation state ambitions to spread misinformation and make a biological agent more effective. You could just make them want to make money and tell them how to spread disinformation that way to make money. That came into an issue with biocyber warfare and crime. Basically, at some point, if you have a country that's committing so many cyber attacks against another country, at what point do you just call it a war when it's, in theory, just crime because they're just, doing ransomware attacks? Okay? And I know you guys might be reading that title there, familiarity with nuclear issues, and thinking, hey, wait a second, this is a bio thing. We're the Biohacking Village. Yes. The issue is, the majority of the U.S. is interested in boosting their nuclear knowledge. They don't even do surveys about biological knowledge. Who here thinks that if they had the genome of a bioagent, that they could identify if it was synthetically manufactured? No one has that data, and the U.S. does not do a good job of advertising how to get that data. There's reasons for that, maybe because they don't want a ton of people knowing synthetic biology at that level. But again, if you don't trust doctors or government officials to tell you what that information is, how do you identify it? Again, it's almost strange because the nuclear threat has a very nice, well-defined symbology. You see a mushroom cloud, that doesn't just happen. You can go, hey, someone might have dropped a nuke right there. It's very easy to point out. Diseases happen every day. Everyone gets sick eventually. At some point, there might be more people getting sick, but how do you tell it's a bioweapon? So here's the key takeaways. Every dollar spent on security is a dollar that isn't profit, which means that all of your health information or hospital information, basically that system has a vested interest in keeping your data not secure or only as secure as legally mandated. Biological agents being modified, that's not a future threat. That's present. You can change them now. You can buy a kit relatively cheaply and use it today. But bioweapons are already pretty bad. You don't need to change them very much to make them worse. You basically have influence campaigns all around you. There's advertising campaigns. We don't call them influence campaigns because in theory they're just trying to make money, but so can other things that affect your biological health. It's still an influence campaign. And again, you should be really worried about who controls your data, especially medical data, because that can be used against you in a biological agent. Now, I'd like to open up the panel for questions. I think we have tons of time. I think we have a full 30 minutes. Basically, any questions you have? Do we have? Yeah, we have one microphone up here. If you guys want to queue up basically at the center aisles, we'll just pass the microphone around. Great talking to you, and I'm excited for your questions.
So I was wondering, has there been examples of bioweapons engineered that had capabilities for like selective immunity?
Oh man. So I don't love this story, but it does amuse me. Has anyone here heard of Operation Coast from South Africa before it stopped being apartheid? Okay. No, I told you this story like 3 times. Sorry. In theory, yes. Someone in apartheid South Africa, a white guy, of course, tried to make essentially a bioagent that would affect black South Africans selectively more than white South Africans. It doesn't work that way. Race doesn't really exist, especially on a genetic level. It's very silly, but basically the guy got upset that he couldn't select for black South Africans. But instead of giving up saying, oh, hey, maybe I'm being silly and racist, goes on to invent ecstasy, which is just a wildlife story. Probably still racist, though.
Hello. So the other thing as well, with biological weapons, one of the things that's really great about them is that there's always a level of plausible deniability. So even if there was one of these weapons out there, we might not know about it. So it could have affected one person and taken them out, and it looks like it was natural causes. And if you're a nation state or a company, you might have a vested interest for this. And this type of warfare has been around since like the shogunate in Japan. They'd have ninjas that would take out, one person for some political means. So it's always a worry. And then conversely, there's a false there's a type 1 error and a type 2 error. So some countries will say, oh, this country is being launching biological weapons against us, but it's just nature. But there's no way to prove either way. So there's a lot of advantage to having them.
Yeah, to add on that, I think it's generally important for people to ask themselves, from this assertion that I have, how can I work my way to that conclusion logically? And do I reasonably have access to that information before I proceed?
So I'm in regulatory, and one thing that everyone's favorite person, one thing that recently we're starting to be mindful of are sequences of concern. So if your company makes oligonucleotide strands that are 50 nucleotides or longer, you have to check if there are sequences of concern against a national database, and that's something that the U.S. is rolling out. But I'm just kind of also thinking, you know, even if you're a vendor selling oligos for whatever purpose for whatever use. That's one way to regulate it, but if it's out in the wild, how would that be detected in terms of those sequences of concern? Because there is some databases being developed.
So the way we detect it is by using those same sequences of concern, unfortunately. So I made a COVID test, and I was ordering COVID nonstop and COVID sequences because I need to order those sequences to be able to find them in DNA. So we're finding a match all the time. So I ordered a synthetic COVID genome. But like, if I wanted to make smallpox, hypothetically, I could just use the vaccine, which is 95% sequence homology. So there's a problem that exists with looking at the actual sequences on DNA synthesizers, because anytime someone is trying to fight the condition, they are going to be sequencing something that looks exactly like it. With AI and sentient AI, we have to be terrified of this because of something called instrumental convergence, right? Which is that the steps to making a nuclear bomb and making a nuclear power plant, for the first 20 out of 30 steps look identical. And you might allow something to go all the way along, and then it takes a detour and you're like, not like that. And then all of a sudden it's over. So I think that there's other ways we need to be policing things around this. And that's cultural, communication channels, making people feel like they're not lone wolves, so that's not a problem. But I think that the real regulation probably can't happen at that level to have any effect, is my opinion.
Yeah.
Good question, by the way.
It's always strange to me when someone says, "Oh, I'm scared of the regulation person." Like, that means I should definitely be regulating you. Like, I should be regulating twice as much as whatever we are now. I think the issue is less about sequences of concern, though. There's a really cool use case with Peter Ney out of Usenex, who basically made a strand of DNA that was malware that infected a PCR machine, which you wouldn't probably have as a sequence of concern because you're looking at it as binary code. The bigger issue, as we talked about before, is low rule factors, because the second you're talking about spreading a biological weapon, it's going to be on some platform, likely be someone can find you. So, for instance, I'm less worried about finding a sequence of concern that you order from, Sears or Amazon, and more about you going out to a farm and getting anthrax, because that's something we can't really control. It's just there natively. If you really want to get a disease, just go to a hospital. There's probably someone that has it. You can just grab it from there.
And also, as additional note, I think there's a lot of importance to, how we fund categorization and, search for new sequences. And there's a lot of work underway which can definitely help to address these matters. But we also must be thinking about, what are emergent discoveries that we may have, and how do we deal with them?
Good afternoon. Thanks for the great talk. My question is, first a statement. Congress is absolutely inept. We've seen the talks of how they try to regulate AI. They can't regulate cybersecurity. And now with the emergence of bioweapons, we've seen them try to regulate guns, and the gun enthusiasts have just made, okay, we can just 3D print guns. So now with bioweapons, not that anybody would make bioweapons for fun, but now that we have citizen scientists that can buy CRISPRs and then just start playing around with it, what chances, we'd have to develop our own community of regulating just like all those other communities regulated. So my question is, when does self-regulation become a prison if governments step in, just as they've stepped in with other community guidelines.
All right, sir, could you clarify the last portion of your question in terms of what you mean by a prison?
What I meant was a prison in that if we self-regulate to the point where breakthrough or even innovation or even study cannot be conducted because we've regulated ourselves, so we've self-regulated, but then governments have piggybacked on that and said, okay, you've done this, now you can't do this.
So I'm from Australia, and we're a country with really high regulation. Even to set up my first biolab, we had to meet with federal agents. Like, that was just a given. But I think a good thing that came out of that was, by being a part of that process, Australia's a different country, I'm going to say, but we've helped write legislation. So we've helped work with them to try and create something that looks better for everyone. I don't actually think it's where it should be. I think it should be a lot more free, but of course I think that. I'm a biohacker. I think, though, that there's definitely been some positives. We've stopped people who we didn't want to be in our community from having access to things they shouldn't have, I think. But it's a tricky one. I think dialogue is a good way of doing it. I personally have run for politics 3 times. Like, I've run federally twice and state once. And by running against the candidate, I didn't have a serious chance of winning. Like, I run against the Prime Minister now. But I did get to debate him in a public forum, and that was a great way to make the things I cared about be talked about on a bigger scale. But I think telling stories is really important. If you have a good story to tell, why it's important, why it's not important, make it newsworthy, and contact journalists or something like that, and publish it yourself. I think those are good ways of changing things. Someone lives next door to Kamala Harris, and someone lives next door to her and next door to her. And if you have a conversation with someone in a supermarket, it could end up going all the way through. So I think that's a good way. Americans are fine at talking, though. Everyone's always chatting to each other. Not quite the same where I'm from.
And just add, additionally, I think it's very important that we all do a civic duty to make our voices heard. It's one thing to have our small spaces where we gripe about these processes, but if we're not playing a role in in any of these politics or discussions on a local or other level, I think it's kind of self-defeating. But additionally, I think it's also very important that as we try to watch and monitor things in our communities, that we make sure that we're as educated as possible. We don't cling to, outmoded ideas, not just on technology, but also on the social processes that guide the use and the development of these technologies.
Thank you very much, Jeff.
Thanks a lot, guys.